Welcome to Study Loop.
So in this problem, we are given a titration curve of an unknown monoprotic acid with a mass of 0.229 gram that was titrated with a strong sodium hydroxide as a base of 0.112 molar concentration. So we are given the resulting titration curve here, and we need to determine the molar mass and the pK of the acid. So first we will determine the pKa of the acid, and as we know that for acids in the titration curve, the pH at the half equivalence point is equal to the pKa value of that acid at half equivalence point. So that means we will first have to find out our equivalence point, and as we know that the equivalence point is basically resided in the steeper portion of a titration curve, actually halfway through this curve, that will be around here. So from here, if we draw a straight line to the volume curve, we'll see that it will be around 25 milliliter volume of base. That means the equivalence point occurs after we added um, 25 milliliter of base. And that means the half equivalence point will occur at the half of this volume. That means half equivalence point will be at half of 25 milliliter. That will be around 12.5 milliliter. So at this volume, the corresponding pH will be equal to pKa. So if our 12.5 is somewhere here, we can see that um, the corresponding pH here will be around 3. So that means that at that point, pH value is 3, and since at half equivalence point, pH is equal to pKa, so the pKa for this acid is 3. Now, to know the concentration, no, so to know the molar mass of the acid, we need to know the number of moles of the base for this titration, and from that, we'll be able to find the number of moles of acid, and from there we'll be able to find the molar mass of the acid. So the number of moles of the base will be just simply the multiplication of its volume with its concentration. So the concentration here is 0.112 mole per liter of the base, and we have and since to reach the equivalence point we have added 25 milliliter base, and we are actually calculating the number of moles for base at the equivalence point, because at the equivalence point the number of moles of base is equal to number of moles of acid. So at equivalence point we have added 25 ml base, so that means at the equivalence point the number of moles of base will be the concentration of base times 25 ml, or 0.025 liter. So from here, we will have a value of 0.0028 mole NaOH. So this is the number of mole of base at the equivalence point. And since at equivalence point, the number of moles of base is equal to number of moles of acid, that means this is the number of mole of acid at equivalence point also. So at equivalence point, we have 0.0028 mole acid. Now we know the number of moles of acid, and we know the mass of acid we are adding. So from these two data, we can easily find the molar mass of the acid, as molar mass of acid will be number of moles so the number of moles equal to mass by molar mass. That means the molar mass will be number of moles, or no, the molar mass will be the mass of the acid over the number of moles. So the mass of the acid here is 0.229 gram, 229 gram, and the number of moles here is 0.0028. So from this calculation, we will have a value of 82 gram per mole, which is the molar mass of the acid in this titration.